Hi to all. So in this video, we see a general introduction to graph neural networks. This blog is beautifully written and I can't hesitate to make a video on this. So the graph neural networks, we can segregate this graph neural network into two words: graph neural networks. We know about neural networks generally. It's a multi-layer perceptron taking some tensorial input and computes certain output in terms of classification of the predictions. So what is graph? Graph is representations with relations between a collection of entities. These entities are known as nodes, and the relations between the nodes are embedded in edges, and it is collectively termed as a graph. So these are the nodes, these are the edges, and these are collectively denoted as a graph. V is for vertex node, E is for edge, and U collectively termed as a collection of interconnected nodes. Further, each node has its own future. In the future can be an n-dimensional vector, and each node is embedded can be an m-dimensional vector, and a global information also can be some p-dimensional vector. Additionally, when the edge type can also be of two types. One is undirected and directed, as represented in this figure. So what are the data in a real world graph? It can be represented as a graph. For example, image, we know that pixel format can have a three-dimensional tensor. For example, 244 cross 244 cross RGB image can be also be represented as a graph. For example, 5 cross 5 pixel can be represented as a graph. 5 cross 5 pixel on the left side can be represented as a graph. For example, this 2 cross 2 pixel, which has been interconnected with 8 neighbors, and those in mathematically represented as an adjacency matrix, and that linking information can be embedded in the blue filled cells. Similarly, text also can be represented as a graph where they are sequential information. It's more structured and sparse and diagonal adjacency matrix. And in practical, there are many other things can be represented as graph. In, for example, complex molecules filled with interconnected atoms can be represented as a graph in the right-hand side, where each atom have different connections with the different types of connections with the different atoms, neighboring atoms, and whole structure contribute to the molecular structure, and this molecular structure will determine the properties of the molecules. And also a social network where the entities or the nodal entities are defined to be of human persons, and how their social and political relationship will be contributing and collectively termed to be as a social network graph. And these can be represented in mathematical sense as an adjacency matrix, where the blue square dots gives you the various relations between that particular person with the other society. And similarly, an image segmentations, and each object or image segment in the things can be identified through their relationship with the other objects through these graphical structures. And these adjacency matrices are not that symmetric or structured as similar to the other pixel-based images or text data. So, what types of problems this graphical structure can arise in the real world? So, it can have some kind of three levels of task. One is a node level task, for example, the molecular structure, we need to classify the different molecular graphical structure, whether it has a particular number of rings or not. For example, this one, which are the molecules having 2 rings, and which are the molecules having less than 2 rings. And similarly, edge level, node level task can be it's something like what are the nodes are belonging to a particular class and what nodes are belonging to the other class. Whether, for example, a molecular structure, whether it is having some particular which nodes, which atoms have some similar attributes compared to the other atoms. Similar like edge level task, how what kind of relationship between these segmentations, whether the relationship is based on watching or the relationship based on fighting or the relationship only of standing level. So these are some of the classification tasks at the edge level. So what challenges do we have when it comes to use the graphical data for machine learning using multi-layer neural networks? So we know that for a neural network input, we take a tensorial input and compute some tensorial output across the multiple layers, and finally we make a final layer depending upon the task we take for prediction, either classification or regressions. But here we denoted that the adjacency matrices are very sparse and it is computationally inefficient. The second one is it's not permutation invariant. So what we do for these sparse entries is the different data structure called adjacency list, where it encodes the information in an efficient way, with a memory and computation efficient way, and also it seems to be like a permutation invariant. So what is graph neural network? A graph neural network is an optimizable neural networks, as mentioned, and it takes the attributes of the graph as an input, and it preserves those graph symmetries, and finally it utilized to identify the structure and pattern inside the graph, and helps to make the predictions and informations contained inside the graph. So the simplest graph neural network would be a simple multi-layer perceptron, where the single at node level, at edge level, and the global level. What I mean is, for each attribute for a node, there will be a separate neural network. For edge, there will be a separate neural network. For a global information, there will be a separate neural network. This is for node level. This is for edge level, and this is for the global level. So for a layer, it will take the graphical information and computes some embedded output of the node level, and it computes the embedded output of the edge level, and it computes the embedded output of the global level. So this is for single layer. As we know that multiple layer perceptron can be extended for any number of layers taking this one. So it can be for an nth layer. Previous layer output will be given fed into the nth layer, and it will be given the output of the embedded will be given to the next layer, and keep on updating the embedded informations at the separate independent attribute levels. So once the multiplayer perceptron and the embedded information comes up from the final layer, and depending upon the task, a final layer would be some, for example, a binary classification. It would be a simple linear layer with sigmoid functions, and identified for node level to identify whether a node belongs to a particular class or not. Similarly, it also happens for the edge level to identify whether that edge is having a particular classification or not. But to be more precise, what the input is having in this type of here is the node information is given to the node, and edge information is given to the edge, and the global information is taken and try to compute the global classification task. How about some kind of scenario where all the informations are contained in the edge level, and we need some kind of prediction at the node level? So for this instant, and also what about there can be an instant where the neighboring node informations are required to obtain the to in order to predict the node level classifications or regression levels. So for this is what the next level of complexity is being increased, where at each node uses its neighboring node informations for aggregating and pooling, and those informations once it's been aggregated is being utilized at the final level and to make a prediction task. And also if the nodal information are insufficient, we can take the information from the edge level, and this information would be fed through a pooling layer, and those embedded and augmented informations will be given to the final layer, and that final layer uses this augmented information from the edge and the node level to identify the classification task. Similar things we can, for the edge level task, we can take the information from the nodal levels and fed into an edge level multi-layer perceptrons and the final stage, and you can able to identify the classifications of the edge, whether it belongs to a particular class or not. Similarly, for the global level, we can give the informations from the global, either from the node or from the both, and to identify the global information task. So this information, that pooling of using the neighboring nodes or neighboring edges to the particular node identification is happen only at the this pooling level is happening only at the final stage. But why not this kind of pooling, and this can be happen at each layer in between that graph neural network. So this is the next transformations and next building block for this graph neural network. So at each layer we try to using this pooling layer to use the information from the surrounding, from node level, from edge level, to identify the node level task, and also we